The behavior of an object submerged in a fluid is governed by the Archimedes principle. Archimedes demonstrates that the body which is completely or partially submerged in a fluid experiences an upward force called the buoyant force. The buoyant force is equal to the magnitude of the weight of a fluid displaced by the object.
The buoyant force is due to the difference between the pressure at the bottom of the object pushing upon it and the pressure at the top pushing down.
Because the pressure increases as the depth increases, the pressure of the bottom of the object is always larger down in the bottom than the pressure in the upper part of the object. The direction of the net force will be upward. The research objective is to calculate the required mass and volume of the ice to design a slab so that the bottom of an arbitrary object will, with a mass m, barely reach the water surface.
Procedure. First, you need to determine which object you're going to use to put on top of the ice. You need to obtain the weight and the mass of this object in order to calculate how much ice you need to use. Once you have the ice and the quantities you need, place the ice on water and then place the object on top of the ice. If the calculations are done correctly, the ice should be completely submerged and the object should be barely on the surface of the water. Settings. We chose an object which is a cell phone, a Samsung Galaxy A3 2017, which has a weight of 138 grams, and we placed the block of ice inside a pool.
We calculate the volume of the ice block using the formula volume is equal to the mass of the body divided by the difference of densities.
After this, we calculated the mass of the ice with the formula density of water times gravity times the volume equals to the weight of the ice and the weight of plus the weight of the body. Finally, we checked the volume of the ice using the formula volume equals mass over density. For the results, we obtained a mass of the ice of 161.8 grams, a total volume of 1.76 times 10 to the minus 4 cubic meters, and a buoyant force of 1.725 newtons.
As the recommendations of the project, we recommend that making sure that the ice doesn't melt in order to keep the same mass, and use a container where the water is calm and without movement.
As a conclusion, we can say that the totality of the volume of the ice was submerged once we added the mass of the phone on top of it, which means that we made our calculations the right way and our theory is right.